Yes, so actually in this session I was meant to be supported by our APEC technical lead architect who decided to have a baby this week and become father, so I was happily jumping in and walking you through our vision of everything is an API, but not all APIs are equal here. Right, so we as IBM, we often talk about agile integration, and this basically covers many topics and many different aspects, but kind of unsurprising to this audience, I'm sure that moving towards an API-led approach is really a fundamental part of that agile integration, we call it. So from our perspective, it covers a couple of different disciplines of our customers basically approaching to modernize their integration estate and approach. It starts basically at decentralized ownership of people that helps basically accelerate agility and innovation and allowing individual team members to contribute in a more in newer ways and basically develop new skills to be able to be self-sufficiently integrate and produce APIs on their own terms. But also a fine-grained deployment is very important from our perspective that helps build independence and increase the production velocity of your integration API architectures. And the third component here, the technology side, certainly is important because we are mostly looking at hybrid deployments, so customers who are having a on-prem and different cloud environments, and moving towards a cloud-native infrastructure eventually has or needs to provide the essential integration capabilities that you need for different integration styles. So this is a heavily summarized perspective from our end of agile integration, and this is basically how it looks. And we see that most customers are moving from a very layered or siloed approach on the left side from existing infrastructures or technology silos to a more API-led approach there, essentially. And back in the days, there's also generally an approach where there's an appetite to have more autonomous teams working with the technologies and with the integration and the API capabilities. And the fundamental topic of integration becomes more or less how do we really define those APIs and expose these APIs, and what do they look like and where are they coming from eventually if you look at the monolithic approach. And more importantly, how do we recognize and also group these types of APIs that we have at hand here? So if you go back to the layered architecture, then we had certain rudimentary ways in which we could separate different types of APIs. We can talk about things like APIs which are exposed within an organization and those which are exposed publicly facing. So internal and external APIs, basically. But if you put it another way, in network terminology, basically, there's often the east-west traffic or east-west APIs in the old technologies, and the north-south one, where basically the traffic is coming from your front door, so external APIs, and east-west, which is the communication within application, within your boundaries. But if you look further to the more cloud-based deployments that we are looking at these days, this kind of east-west traffic is not really happening anymore. It's not a way to differentiate anymore, because any kind of traffic, even if it's internal or even within internal applications, is going kind of north-south from different cloud platforms to your on-premise deployments and even to your mainframe backend systems, if you will. And furthermore, even within a single cloud vendor, there might not be any east-west traffic because any traffic even within that cloud is happening through external interfaces and needs to be in a north-south kind of fashion there, if you will. So in other ways, we used to categorize APIs was the type of protocol that was being used within the applications. So if it goes back to the days when we talk about APIs, like 15, 20 years ago, where not APIs are REST APIs. It could be just a IPC inter-process communication piece here within an application. It could be a CORBA-based communication between different applications here from the Java world, if you want to. And then specific APIs or specific applications have been exposed as an API that are coming from this monolith and basically this integration bus type of deployment for specific functions. That's basically the birth of APIs there. But if you look and try to map this to a modern container-based or Kubernetes-based deployment, that actually doesn't really apply anymore. So it doesn't work with a microservice-based application. Because a microservice application, or indeed in a modern decentralized application, we start to break up the pieces into each having their own individual container sitting on the network. So pretty much everything in a network is an API call. And there might not be, or there might be all REST API calls. So how do we differentiate between these calls and make it manageable? Maybe different levels of governance are necessary inside an application or outside an application. So if we carry this on, essentially, if we started to be building things in a more fine-grained microservice style of applications, then we are building applications in microservices, and we could end up literally with an ocean of microservices or an ocean of APIs that need to be called and that need to be handled in a way. So if we try to bring back the idea of application boundaries, like you see in the diagram here, using some of the techniques that are available on Kubernetes, on container-based deployments, to control boundaries in that sense, or network-wise boundaries in that sense, we can make still a nice grouping and handle these services probably a bit differently to some extent. And these services that are found within the microservice boundaries, they might then, again, have a level of API management on top of them to have a controlled level of governance or security to expose them externally, as opposed to a communication that you have within the application boundaries, if you will. So that leads us a bit to the topic of inter-service or inter-microservice or inter-application communication. So our vision or view of a strategy here is a bit that we have an inside and an outside approach. So things inside the application boundary communicating perhaps over a service mesh, and we'll talk a little bit about that in the next slide. And from the outside traffic, providing a gateway and a portal in order to be able to subscribe to APIs and make them discoverable in a way. So two different styles, basically, of service handling. So a service mesh is really designed as the one sitting on OpenShift, for example, like Istio. It's really designed to assist microservice components sitting inside a specific domain to communicate with each other and to save you from having to put extra code inside these microservice applications or components to achieve things like circuit breaking patterns, rate limiting patterns, and so on that you see on the left side here. So it's actually quite handy in that respect. And it's a powerful mechanism almost creating the application boundary itself. But you could use API management, as you can see on the edge of that boundary, to have a bit, as I said, a higher level of governance and have other features available that might make it necessary in that context. So we've spoken about synchronous APIs, and probably specifically REST APIs, if they were the only kind of APIs that we see today. But of course, that's not true. There are historical services like web services, SOAP-based services, and then there's messaging interfaces like IBM MQ, MQTT, RabbitMQ, and much more things like Graphql, for example, that are working in the API space and are behaving like an API, obviously. Back 15, 20 years ago, we had hundreds of different types of protocols and standards, which are mainly proprietary and which are hard to handle. And now I would say there's probably around 10 which are very standard-based in that sense. That brings us basically to this topic of beyond REST and handling it this way. So one of the things you saw on the slide before is GraphQl, which is, allows you to talk to multiple backend resources in one go, whereas REST API might be very chatty for that type of interaction if you want to query various different backend resources and basically have something that is similar to SQL as a query language to aggregate lots of information in a single interaction. So it's very different in the way it is designed and governed, but GraphQL, on the other hand, needs a different level of control and governance, basically, to ensure it's not doing some high-cost queries against backend systems and federated services in the backend system. So there's a lot of benefits we see in this type of protocol, but it also is something that needs to be handled and enabled by your API management platform in that respect. So let's go back and talk about the idea of these asynchronous protocols as also being a type of API. When we're talking about HTTP REST-based APIs, then we're talking about synchronous operations. But there's also a way to talk or to work with event and messaging-based endpoints or systems like JMS, AMQP, and Kafka. And we're seeing both within the application and across the boundary of an application, increasing use of asynchronous communication. That is something that, in our perspective, might ask for a proper type of interaction and also for scalability and resilience in the sense of a managed platform there. So we believe these architectural components for this type of event management should be composable, where Kafka provides the commonality that brings the features together. And we would use frameworks such as Flink, Spark, etc., to have a commonality for the Kafka platform when you use it in that sense. So you should be able to swap them out, and we are aiming at providing a capability at each level that gives you this composable architecture here in that sense. It's kind of a layered approach, so obviously for the event part, the event distribution layer is based on Kafka, could be MQ, MQTT, MQP, and it's basically built on open technologies as a framework or as a base for this piece. And then we see on top of that a discovery or management layer. So we call it event endpoint management, which is similar to API management in that sense. And it enables existing events to be discovered, to be consumed by user, while basically upholding enterprise policies to protect your backend systems, perhaps. Data access, data resistancy. So these, in the sense of application integration, provide mechanisms of application integration and access to data and backend systems. And examples for that would be coming from the API management side, the typical disciplines of having an API gateway for decoupled routing, for traffic management, security, protocol translations, and stuff like that. And with the typical components for developer portal and management versioning of APIs. That's something we all know, specific for APIs, but it's almost in a similar fashion applicable to the space of Kafka and event broking. Just for the idea to have a basically a log or a history of event information ready at hand, and you can basically then promote it or advertise it through an event gateway, use a developer portal to make it discoverable, subscribable, and have an event endpoint manager basically to version and evolve these events. And event endpoint management with Kafka and the Kafka brokers here is basically our first take of extending API management to the topic of event management. But we also saw that there's other candidates waiting and to be distributed in a platform like this here. And last but not least, we are envisioning, but this is more a future talk, what we've talked about so far is basically part of our stack and platform, is the insights and action capabilities. So it's basically the aim is to perform stream processing, which we know from the Kafka side, so looking at patterns across a window of events within a stream. And this can be done with Kafka today, but it's basically a pretty complex and it's a programming exercise. And against technologies like K-tables and K-streams. And our aim is to make this digestible and use technologies like Apache Flink, for example, that makes it basically almost open for a citizen developer to work against a Kafka stream that way, and build a composable approach like this to build your applications for asynchronous APIs and manage it with event streaming here. So we're only starting to see this in the last year, the emergence of event and event endpoint management, really as an extension of API management for things like events and messages and basically for a roadmap going ahead. So it's a maturity that is starting from raw event runtimes such as Kafka, all the way through richer and full API management facilities that you're looking for, that can manage both APIs and also eventful APIs and other things going forward. So if you're bringing all these things together, and we see that boundaries are important to recognize the APIs we are exposing, especially in a multi-protocol world and a multi-form world, a number of different types of interfaces that come together to provide these APIs in a componentary set of protocols, if you will. So microservices in combination with different API flavors, if you will. So essentially, everything basically communicates as an API, but it doesn't mean that all APIs are equal, depending on what context you're looking at. And eventually, that is for us basically a way to go forward. We are researching on, and we provide different means to manage these type of extending or growing API form factors here. A couple of resources on this, especially for event-driven architectures. We are providing a couple of papers, practitioner guide, and basically a good set of blogs and information on our event endpoint management. And specifically, you want to get your hands on this and a bit more of a background. There's a session from my colleague Pete Jessup tomorrow in the workshop that basically walks through these capabilities and basically brings it to life. All right. Very important for us. So it is basically part of our way from traditional integration to a more agile form of integration with lots of technology pieces, but also specifically the people and the process side we think is very important on this one. Not only the architecture and technology side where we can provide a lot of capabilities, but to reap the benefits of a platform like that and of a more decentralized ownership of these platforms is actually something that has a strong factor of people development and transformation here to benefit from the agile methods that are behind it. So there's quite a bit of content on this that we are publishing, and we actually just looked at a very specific capability in the broader context of agile integration, but I think something exciting looking forward to move the journey of API management forward for us. All right, thanks.
Thank you, Bernd. I think we have a couple minutes for some questions. If there's any questions for Bernd.
Bernd, how do you see transactional type of communication protocols like point-to-point messaging playing a role in the whole agile integration space?
Yeah, I mean, if you look at the pitch here, it's basically an extension of what we've talked about. You know, we're looking at eventful messaging right now, like Kafka that we are managing as like an API, like an endpoint that can be subscribed to, discovered, and can be accessed in a self-service fashion. And the MQ, the messaging protocols, MQTT, and pretty much all the ones that we saw on the, I think, third last slide or something, are candidates to be handled there. So the idea is basically to move forward with many different API styles and flavors, but have a common portal and a common infrastructure for managing these APIs and endpoints.
Bernd, I can't help but to notice you mentioned not all APIs are equal, but there was also very different personas, right? So in terms of technologies and the different people, which is more important, like the people or the technology?
Yeah, definitely. So it's definitely the people. So you can do so much with technology, and it might work in theory and in the labs while building the capabilities. But it's all about an organization adopting these practices and basically enabling people, enabling decentralized teams to be able to work with the capabilities. It reflects back certainly to technology to some extent because everyone is building more intuitive user interfaces, more softened capabilities like the ones we introduced here for stream processing and just stuff that basically enables the citizen developer to become part of the ecosystem. But eventually, everyone has to live this kind of principle to get all the benefits out of it. Yeah.
Sounds great. I think we have time for just one more. Okay. If there's no more questions.
We're actually 2 minutes early. All right.
Okay. Well, I think your contacts are in the slides, and this will be recorded.